Yay!
Here's another example of using our kinematic formulas. But this time I'm going to use a deceleration just so you can see how the minus signs should work out. So here's another boat. For some reason, I like to use boats in examples. I don't know why. So suppose I have a boat that's traveling at 16 meters per second. That's actually pretty fast for a boat. But anyway, so it's traveling towards a dock, and the dock is 60 meters away. And the idea is that the acceleration of the boat is a minus 2 meters per second squared. So that's a deceleration, right? So that means every second, the speed is slowing down by 2 meters per second, 2 meters per second, right? So the question is, if this is the rate at which the boat decelerates, will it hit the dock or will it stop in time? So let's see. There's always, whenever you work with these kinematic formulas, there's always a couple of ways that you can do it. So your way may not match your friend's way of solving the same problem. You may use a couple of formulas, and then your friend may use one formula, but you should always get the right answer. So it's cool to think of other ways you might possibly do it. So here's one way. One way we could do it. Let's use this one. Let's do, because we're given an A, right? And there's a distance. Let's see if we can find how long it takes the boat to slow down, right? So here's one thing we could do. We could do delta V, let's use this one, is A times T. And remember what delta means. Delta always means final minus initial. So V final minus V initial is equal to A times T. We want the boat to come to a stop at the end. So that means this V final, we need that to be 0. The V initial, we know what that is, and we know what A is, right? So it looks like we can solve for T pretty easy. So this means that I'm going to be careful. I got to keep all my minus signs. So minus 16 is equal to, what is A? It's minus 2. So this is going to be minus 2 times T. And so now if you solve for T, look, those minus signs are going to disappear, as they should. You should always get positive times. So it's going to take 8 seconds for the boat to go down to 0. And then if you think about it, that ought to make perfect sense. If the acceleration is minus 2, that means we're losing 2 meters per second of speed every second. So if you start off with 16 and you lose 2 every second, it makes sense that after 8 seconds, you're down to 0. So cool. And whenever you're solving problems, if you get a negative time, that usually means that you blew a sign somewhere. So it's good to go back and make sure. You should never get a negative time. So here's an example where the minus sign should cancel. Okay, so if it takes 8 seconds to come to a stop, then I look over at my kinematic formulas, and can I get a distance? How far in distance will the boat travel during those 8 seconds? Well, it looks like I can use this. V initial times T plus 1/2 AT squared, right? If I know an initial velocity, a time, and an acceleration, I can get distance. And I know all of those things. So this is going to be 16 times 8 minus, because A is going to be negative, so it's going to be 1/2 times 2 times 8 squared. All right, let's see what all that is. 16 times 8, that looks like 128. And then this 8 squared, what is that? 64, right? Half times 2 is 1. So it's 128 minus 64, or 64 meters. Uh-oh. Boom, hits the dock, because I've only got 60 meters. So the boat will take 64 meters to come to a stop. It's not going to make it. Boom, it's going to hit the dock. Cool. Well, not if you're in the boat. There's another way you could do it, and this way you might have seen immediately. Notice here we used 2 formulas to get the answer. We found the time, and then we found the distance. You could just go right to it, because one of these involves V final, V initial, 2A, and the delta x is what we're trying to find. That's that last one, right? You could just jump right to that last one and solve it all in one go. That's fine. There's nothing better or worse about that necessarily. I mean, it's only one formula, but anyway, you could use that if you want. V final squared equals V initial squared plus 2a delta x, right? So that means that the delta x we're going to need is V final squared minus V initial squared over 2a. Just doing a little bit of algebra. Again, V final, I want that to be 0. V initial squared is going to be 16, so I have minus 16 squared. Don't square the minus sign. It's minus that thing squared. The squared binds to the VI before the minus sign. So the minus sign doesn't go away right there. And then 2a is going to be 2 times the minus 2. Ah, see? Now those minus signs are going to go away. So this is going to be, I'll just do one more step to show. This is going to be minus 16 squared. What is that? 256 over a minus 4. And now, sure enough, the minus signs go away. And then once again, we get 64 meters. So just as we should, we get the same answer, but we just use one formula to get it instead of two. Doesn't make any difference. You can do it whatever way sort of makes sense to you in your head. You can do that. So just a nice illustration of using almost all of our kinematic formulas.